This is lesson 12, activity 4, building quadrilaterals. So there are two sets of lines in this activity. One set has lines that are all equal, so 4 equal length lines, and the other set has 4 lines as well, but 2 of those lines are one length and equal, and the other 2 lines are a second length but equal to each other. And so your job is to form as many different quadrilaterals as you can and compare your quadrilaterals with others in the class who have the same set. Now, a quadrilateral is a 4-sided figure. Now, this whole unit has been building up to recognizing things that are congruent, or images that are congruent or the same as each other. And one way to do that is to look at equal lengths. Well, the sides are all equal in this activity. So what are you going to look at besides the equal lengths? Is you're going to start looking at angles. And I'm going to show you how this might look in Docere. So I started with 2 congruent circles. So this is one circle and this is a second circle, exactly the same size, just moved over a little bit. And if I draw a radius in the circle on the left, these 2 lines are equal in length. They are both radiuses of this same circle. Likewise, if I draw a radius of the circle on the right, these 2 lines are radiuses of the circle on the right. It turns out that all 4 lengths are equal because these 2 circles are congruent. And just to prove that a little bit more, this is a radius of both circles. So if you look at the circle on the left, this is a radius of the circle on the left. And if you look at the circle on the right, this is a radius of the circle on the right. So all of these lengths are equal. And this triangle now that's been formed is an equilateral triangle because it's made up of the radius of the circles. So each length is equal, and that means that each angle is equal. Well, in an equilateral triangle, if each angle is equal, there's 180 degrees in a triangle, so each angle has to be 60 degrees. And so the pink shape is called a rhombus. It is a special parallelogram. So a parallelogram has 2 opposite parallel sides. So this is one set of parallel sides, and this is a second set of opposite parallel sides. And when each of those lengths are equal, that is called a rhombus. And if you look at one angle across from the other angle, so through the diagonal across the figure on the opposite side, those angles will be equal. So this is 60 degrees and this is 60 degrees. And right here, this is 60 degrees plus 60 degrees, so this whole angle has to be 120 degrees. And so its opposite angle using the diagonal across the shape is another 120 degree angle. So if you notice that the triangle adds up to 180 degrees, there are 2 triangles, so the whole quadrilateral, the angles add to 360 degrees. All right, so I'm going to start here and imagine that this is 4 lines. You might notice that there are 2 lines here. One is the radius going this way and the other is the radius going this way, but they're the 4 lines, 2 are on top of each other. If I move it over just a little bit, you can see that. So the angle, in this case, the large angle is almost 180 degrees. The small angle is almost 0 degrees. So if I go back, that small angle disappears and the large angle becomes 180 degrees. Well, there's 2 of them. So there's 2 of them, 180 degrees and 180 degrees. And so 2 times 180 is 360 degrees. Also, this is a parallelogram. It's one set of parallel opposite sides and a second set of parallel opposite sides. So as I move that circle out farther, this angle becomes it's smaller. It's moving away from the 180 degrees. This angle is larger, so moving away from 0 degrees. I keep going. Eventually, this angle gets smaller, this angle gets larger, and we get to the 60 degrees. So this is now 60 degrees, and this is 120 degrees. So if I draw that line, this would be 60 degrees, and together it's equal to 120 degrees. So this is back to the equilateral triangle. Now again, parallelograms, a set of parallel opposite sides. So this is one set, and this is the second set when each of the sides are equal length, it is called a rhombus. Now here's a square. A square is a special parallelogram, and it's a special rhombus. So one set of parallel opposite sides, a second set of parallel opposite sides. All the sides are equal length, so that makes it a rhombus. And what makes it a square is that each of the angles are 90 degrees. So you continue out. And so what you're going to do is put your four lengths together and compare them and figure out who's made the same or congruent shapes. So what are you going to look at? You have to look at the angles because each of these lengths are the same. So you're going to realize, gee, in every case the lengths are the same, so that doesn't tell you enough. It is the size of these angles that tell you. So you can trace them, you can lay them one on top of each other, do something to compare them. If you do docere, you could probably get a protractor in here and actually measure them, or just do it by looking at examination, and you can tell which are close, maybe not exact. So you keep going. Eventually, this is approaching 180 degrees now this way. This is approaching 180 degrees. So again, 2 times 180 is 360 degrees, and this is going to approach 0 and eventually become 0. And it's the next one that happens. So it goes to a straight line. Now, this is when all the lengths are equal. So they are radiuses, or radii, of the circle. So all the lengths are equal. You always get a rhombus, which is a special parallelogram. 2 opposite parallel sides, equal parallel sides. All right, so what if the circles are different size? So now we're going to make those lengths different. So remember, another set has 2 lines that are longer. So let's look at it this way. This is the radius of the larger circle. This is, again, the radius of the larger circle. So these 2 lengths are the same. But this is the radius of the smaller circle. So this radius is shorter, but it's the same length as this radius. So again, it's shorter, but these 2 are equal, and these 2 are equal. Well, if you have that, if you put those together, and if you place the equal lengths adjacent to each other so that they meet, it forms, in this case, what's called a dart. This is called a concave figure. This is going inside into the figure, so it's concave, and you get a dart. If you keep on moving this circle out, this angle is actually getting smaller, and this angle is moving more towards where it's going to flip out the other side, the other way. If you line them up, now you get a triangle. These 2 sides are equal. This is called an isosceles triangle. It's actually an isosceles right triangle, but that's a lesson for another day. Keep going. So now you get something that's called a kite. So now instead of being concave, this is convex. So it's going out. So these 2 sides are equal, but they're shorter than these 2 sides. And you put the sides that are equal together so they meet. You get a kite. So keep going. So once again, how are you going to figure out whether you're making a congruent figure compared to somebody else? You have to look at the angles, and actually with kites and darts, there's another shape that you can form. I'll show you that in just a second. So keep going out, and so you can compare these, and mainly you're going to look at angles. Once you realize it's a kite, you're going to look at these angles. These angles are getting smaller. These angles are getting larger. Keep going. Eventually it's going to be 2 180-degree angles. Now, if I took half of a kite and I reflected it over this x-axis like that, so now I get the kite. If I take this half again and reflect it over the y-axis this way, now I'm going to get a parallelogram. So this has 2 sets of parallel equal sides that are opposite each other. So this is one set of parallel equal sides, and this is another set of parallel equal sides. These lengths are shorter than these lengths, but this is a parallelogram. Now, if you remember, if you reflect an image once over the x-axis and then over the y-axis, that is the same as a 180-degree rotation. So if I take that half of the kite And I'm going to turn that into a triangle and rotate it 180 degrees. So if I rotate it around, if you remember what you get when you rotate something 180 degrees, you get opposite parallel sides. So this side rotates over to here, it is opposite and parallel. This side rotates over to here, it is opposite and parallel. So what's the shape you get? You get a parallelogram. Just like the reflection, here's the reflection, you get the same parallelogram if you rotate that shape around. So those two parallelograms are the same. And finally, if you either rotate half of a dart or reflect half of a dart, two reflections for half the dart, you're going to get the same, you're going to get a parallelogram in the same way. So if I take half that dart now, and I'm going to reflect it, so I'm going to show you that reflection. So here's the original dart, and I took this half that's pink, moved it down here, and I'm going to reflect it over the y-axis. So there's the y-axis vertical line, reflect it over that. Remember, it's to reflect, it's an equal distance on the other side of the line of reflection. So the 2 points are here, and connect all the points, and you get half the dart that's reflected. If I translate this back up, or slide this back up there, what's the shape that you get is a parallelogram. Now this would be the same if I took this half, and rotated it at 180 degrees, I'm going to get a parallel side that's opposite but parallel, and a parallel side here that's opposite and parallel. So I'm going to get another way of getting the same parallelogram. All right, so this is lesson 12, activity 4, building quadrilaterals. So take your lines, put them together, see who's making the same or congruent shapes. And the main thing you're going to look at in this case are angles, regardless if you have 4 equal sides or 2 sides that are equal and another 2 sides that are different length but equal to each other. Building quadrilaterals.